Welcome back to Let's Try or That. I'm Gilles, and this is part 2 of designing and machining a grinding fixture. So this, by the way, this is a detailed explanation of how I'm designing and machining this thing. So it's a little longer, it's going to take a few more episodes, but it's really meant for people who want to learn a little more in detail the considerations of what it involves. Now, at the end of episode 1, where I left off, where it was time to design the features and then carve them out of the base of this fixture, right? So I want to show you what's involved again, or repeat. So here's a 30-degree angle, which is for the secondary grinding of an end mill. This is the 5-degree angle that is required for the primary. And this here is the 2-degree angle. Now, the interesting part is that the 2-degree angle and the 5-degree angle have to be milled at the same time. So that's a compound angle, right? So we're going to be like this, carving out this way, and of course carving out that angle as well. And see here, for example, this would have been, like if it had been just a normal 5-degree milling, it would have been down here, same as on the other side. But because it's we have this 2-degree that we have to include, then the 5 degrees is going to end up being carved up here. And that's 300 thousandths from the bottom of the base. Just to keep it simple, the 5-degree and the 2-degree have to be milled first. And then, once that's done, we'll flip this on its other end and we'll carve out this 30-degree. Okay, so what are some of the consideration other than those angles that we have to take into account? Well, first of all, we have this feature here, and in here are going to be 2 washers and our thrust needle bearing. They amount to about 4.1 millimeters, and discussed earlier on how the rest was going to be space remaining for the nut that's going to hold down that sleeve, and then any kind of loose that we could get in order to carve out this here. So I've made some lines here, right? So what I've done is I've taken a square like this, made a line up to know where the edge of this here is, and here's where it intersects. Well, right there is exactly 300 thousandths of an inch. So I'm going down 300 thousandths of an inch. So what does that mean for that sleeve and that nut that's going to reside in there? So let's look at that. So now we're seeing the inside of the bearing seat on the underneath of this picture. And you see the line that I've drawn out. Now that's 300 thousandths from the bottom of the base. So I'm going to take the needle thrust bit and I'll put it in there. And then after that, we should still have, we need to have another 5 millimeters. All right, I've inserted the thrust needle bearing in there, see, and the appropriate washers. So here's a height gauge, or depth gauge, sorry. And so I've got this sitting on the needle thrust bearing. Okay, so how much space do I have? I measured it and saved you the time, and we have 10.21 millimeters. We need 4.1 for the needle thrust bearings, and I said I needed 5 millimeters at least for that nut. So we're good. So now we need to figure out how to set this up at the mill in order to mill out the appropriate angles. So let's do that. Well, that was a failure. So far, no el bueno, my friends. Here's what it comes down to. To cut a compound angle, at one point, you need to have the block sit in, and it has to be tilted. So the ends need to be cut at the 5-degree angle. There you go, first 5-degree angle at the end. Now I gotta do the other side. I've made 5-degree angles at both ends of this fixture. Underneath, what I've got is a compound angle block. So now I'm about to start again, and I've got my fingers crossed that this might work. Let's see if that experiment works. Gotta check all these angles. So I've now got my angles cut, and both angles, the 2 degrees and the 5 degrees, were cut at the same time. I tried various methods. If I had a really good compound vise for milling, that would have been a piece of cake. But unfortunately, the one I used made everything sit too high, and it wasn't sturdy enough, and I ended up just wrecking some end mills, so that was no good either. Started thinking that perhaps I could cut a block to support the work and make it steady and then held in my vise. When you tilt things at 5 degrees, and if your block's a square, well, then all of a sudden it's not being held correctly in your vise, so that's not going to be sturdy enough. It's not going to work. So the solution to this was pretty simple for me. I cut 5-degree angles on both of these ends. And so what it allowed me to do is basically support the work with my compound block. And then because they were cut at, the ends were cut at 5 degrees, this is the side I had cut, then I was able to hold this piece firmly in the vise and then cut this side, so that worked out really, really well. That was the solution that I came up with, and it turned out just great. My angles are nearly perfect. Boy, in a project like this, it's easy to start forgetting stuff when there's so many things to do. So essentially here, I had forgotten that we got to carve out this 30-degree angle. But got to remember, we've taken out 5 degrees, so we only have to cut 25 more degrees, right? Zip, take a trusty, whatchamacallit here, put it on here, and verify with the mark we had it. And it's bang on. Reached the last pass for this. Just gonna smoothen those rough edges a little bit. This is the final look that I've obtained with this base fixture with that belt sander. So I knew I couldn't put this on the surface grinder just because of all the various angles. I really have nothing to hold it correctly on the surface grinder. Went for the next best thing, so you know, I'll probably polish this slightly more eventually because I just might blacken this thing. Well, it's now time to plan the sleeve. So here's what I've got. I've affirmed the various numbers. So we're going to do a turn down to 55 millimeters. That'll be the dial. We already know that the sleeve indicating part, this here, is 35 millimeters. So because the hole in the fixture is 1/1000th over 35 mils. So I've calculated the various minimum spaces available. For example, this is shorter here, so I've measured this. This turns out to be 8.5 millimeters. So that's the space we have to put in threads and a 4.1 mil thrust bearing. So it doesn't leave a whole lot of space, but I got to make sure I don't go past the bottom of the fixture, of course. The overall height of this piece is 57.1 millimeters. So now it's time to cut a chunk of this stuff and get started. Should be fine. Okay, now we've got a nice surface to measure from. The finish is absolutely unbelievable. So let's take a quick measurements and then we'll find out how far we need to go. All right, our target measurement's 55 millimeters. So that's 2.165 inches. And this is where we're at currently. So there's 328 thousandths to cut down. Here we go. We are at 2/166, which is just fine. Next step is to turn down the diameter to 40 millimeters, and that equals to 1 inch 574 thousandths. So we've got 591 thousandths to take off on the diameter, and I've got to take that off over a length of 20 millimeters, which is 787 thousandths. Wow, look at that finish. Now I need an undercut that is 5 to 6 millimeters wide and then 3 millimeters deep. This, my friends, is an M40 by a 1.5 millimeter die. Well, in the past it's been a little bit difficult to use, but let's see what happens this time. No points training, so I might as well use the lathe to do it to help out. There, just like that. Well, looks good. This part of the operation requires a little bit of patience and just got to think through this thing here. So if you're doing something, making their ER32, you know, anything, you likely have those sockets, or you know, the collets. So take one, use something that's really straight and put it into like a chuck for your tailstock, and then use the rough measurements on your compound slide and set them to 8 degrees. So you'll be close, sort of. Then set an indicator. Make sure it's sort of lined up in the center of the tool. And then take your compound and run it along that surface. So that's what you got to do in order to get things properly aligned on your compound. All right? It is now time to drill a 1-inch hole right through this. Okay, let's start with a standard drill. Now time to bore this thing, the angle. So let's get that thing started. Target. Excellent. Now, let's try with an end mill. I want to see the nut go there, just about there, so everything sits correctly. Yeah, that's nice and firm. I want to make sure we use as many as a thread as possible on this thing here. Okay. Now for the next feature. I'm going to turn down this all the way down to here to 35 millimeters in diameter. If you're new to this machining stuff, first thing to be wary of is your jaws, making sure that nothing hits anywhere, okay? So let's get started. You can see, using different tools, I'm able to carve in the different aspects of it so that each tool can carve out as much as it can. And in the end, when I get to this, then I'll use my favorite carbide tool and carve out the rest. See, that stuff's a bit of a nightmare to manage, so be cautious. Alright, this is where the careful work begins. I have to measure the smaller part of this diameter, and I believe it's here, and then carefully carve it out till I reach within 10 thousandths, and then we'll play it by ear. Saw me clean that up here. So the part of the shaft that's cleaned up measures 1 inch 396 thousandths. Our target is 1 inch 378 thousandths. So that only gives us 18 thousandths to go. So at this point, I'm going to clean up the rest of that sleeve, this part here, and then carefully bring it down until I reach within 1 or 2 thousandths, perhaps 2, so that I can use emery cloth to bring it down to proper size. So I've got about 10 thousandths overall. Some places a little less, some places slightly more. And but this is the area that has to be very accurate. The rest here is threading, so I'm not concerned about that, because I can customize that to whatever. But this here has to be exactly 35 mils. And right now I'm just trying to figure out the best way of achieving this. I've got a carbide cutting tool set upside down, so I'm going, I'm reversing essentially, and this way I'm going clockwise. This is a threaded chuck, so you're going to be very careful when you do that. I'm only taking maybe 3-4 thousandths cuts at a time. So that's where I'm going now, and just one tiny step at a time. Extremely slowly on the feet here. It's done by hand, so I'm trying to get the best possible finish out of this. I've reached the scary part of this job. This is where I always start choking. You know, I'm within a couple thousandths here and there, and at the front, you know, almost like 8 thousandths, but I've got 5 thousandths to play with, or 5 millimeters, because that goes into the bearing sleeve. The rest, you know, the rest of the 24 millimeters in length is what really has to be precise, and then the bottom part, then it's no problem. So I'm going to use some emery cloth now, and what I'm doing is measuring at various locations on the shaft, but I can see visually that it is not even. And now it's time to start sweating. Be careful if you're going to do this. For one of the million measurements I'm going to have to take here. Okay. Remember that our target is 1 inch 378 thousandths. I guess at this point I could probably use the millimeters, but then I can't relate how much. See, this is 386 here at the top. About 1/8 of an inch down, we're at 84. Another inch or 1/8 of an inch further, I'm at 81. 82. 89. So I'm gonna have to actually I'm gonna leave that part off for now. So I'm gonna the top part is what I want. So that I'll keep working on that. Okay, so I finally completed this particular exercise here, and everything is within 5/10 of a thousandth of an inch. So I'm satisfied that this is going to work. So now it's time to very carefully cut this off and proceed to the next step. Okay, well, I thought maybe I'd cut it too short, or drilled too short, but I didn't. Here we are. There's the piece there. So now, gotta clean this up a bit, and the next part, I'm gonna make this fit into the base first and see how that looks. But then we gotta do some, then we have to make some threads at the bottom here. So I've now reversed the sleeve into my chuck, and I've got some aluminum jaws here to protect the thread. Now one of the important things to do here is to make absolutely sure that when the base sits on the magnetic chuck, that it sits flat. So you don't want this to extend past. So we need to make a practical test here. Just slide the needle thrust bearings with its appropriate washers. Look at the fit, absolutely perfect. Very happy with that. And you see now this here, we need to make sure that this doesn't stick up. So we can take a rule and go like this, and we're good. So now these thrust bearings do not compress, so it'll remain the same. There might be a tiny bit here, but we'll see. I can always just grind that off, and it won't be very much, like maybe a couple thousandths of an inch. So just remove this and the bearings. Okay. Now what I need to do is do the threads for this thing. So I've got to protect 20 millimeters of that, and the remaining part, which is what, 14.1, will consist of threads and of course a small undercut. So let's get prepared for that. Alright, it's time to cut some threads. I'm going 20 threads per inch here. That's going to be very nice. Excellent. Okay, that's enough of that. Now it's time to take measurements and make a knot.